This is page 37, and we're dealing with some vocabulary in geometry. A lot of geometry is vocabulary. You have to really understand the terminology to be able to understand the question sometimes in a geometry book. So I want to make sure that we cover these key terms. And the first one is point. Point is a pretty common word in English vocabulary, but point in geometry is simply a fixed position. It can be in space, it can be on a plane. We're just going to say it's a fixed position. So for example, here is point. I'm going to call this point A. Here is point B. You get the idea. Points are identified by coordinates if you're talking about a graph. Let's say they're named by coordinates. So if this were an XY graph, you would have an X coordinate and a Y coordinate. That's on a graph. But a point can be anywhere. It can be any 3D position, any two-dimensional position. It's simply a fixed position. Okay, the next word that we want to define is line. And a line is a straight path important that it's straight, that is endless in both directions. Now that's the key to identifying a line. It's endless in both directions. So a line is going to be designated by arrows. So if you want to draw a line, I'm going to draw a horizontal one first, right here. And it's endless in both directions, so it will have arrows on the end. So this is a horizontal line. Lines can pass through points, but it doesn't change anything with respect to the definition of a line. You can rotate a line. So here is a horizontal line, but you can turn it and you are not changing anything with the respect of a line. It is still, by definition, a line. Lines can be named by their points. So we could call this line CD. And the symbol for that is line CD. We could also have line DC because the line is endless in both directions. You can also name lines just by letters. So for example, this one needs to be perfectly straight, and that's leading me to my next point here in just a second. So we could just call this line A. Very often if it's done that way, they will be lowercase letters, so that would be line A. It's very important to me that you know that this is not a line by geometry's definition. If you're in kindergarten, that's a line, but this is not a line by the geometric definition. Lines have to be perfectly straight. Okay, I think, let me take a look ahead here. I do believe that I need to talk to you about parallel and perpendicular here. So let's go ahead and define that. Parallel are lines or rays or segments that are equally spaced or equidistant is the name in most geometry books, equally spaced, and they never touch. So for example, I think I'm going to put those right here. This line and this line are an equal distance apart all the way down the line, and they never touch. They never would touch. So if this is line M and this is line N, we could say that, let me write it in proper form, line M is parallel to line N. Parallel. And then we have the word perpendicular. Actually, before I do perpendicular, let me give you intersecting. Let's look at this one. Intersecting lines cross, just like roads that intersect. Intersecting lines cross each other. For example, these two. Here's the point of intersection. Those are intersecting lines. Now let's get perpendicular. I think there's a question on the practice test about perpendicular. I believe it's practice test 1, number 20. Perpendicular cross at exactly 90-degree angles. So perpendicular lines do intersect, but they intersect at 90-degree angles. So you'll have one that is perfectly straight this way, one that is perfectly straight this way, and you're getting that 90-degree angle in there. Here's the point of intersection. So let's give these some names. Let's use Q and R. Q and R. So I could say that line Q is perpendicular to line R. Lots of vocabulary on this page. A couple more terms that I would like for you to at least have seen. This line right here that I drew is horizontal. If you think about sitting on the beach and looking at the horizon, it runs left to right. So this is a horizontal line. Line A here is a vertical line, north to south, up and down. So those are important terms to know as well. Okay, let's talk about array, R-A-Y. This is a word that we hear sometimes, especially in relation to the sun. Array is a straight path with one endpoint and then it's going to be endless in the other direction. For example, let's start with a point. And let's pretend that this is point S so that you can think of that as the sun. This is the best way I know to show you array, because the sunlight originates at that point, and then 8 minutes later it reaches Earth, but it has traveled in a straight path. So maybe over here is the Earth, and it can't, that's not a good, it's not a good description because it can't pass through the earth. But you get the gist. This is called a ray. This is endless in one direction, and it has an end point. This is a one-way street. A line is a two-way street because it's endless in both directions. But we could call this ray SE. You may not call this ray ES because E is not the end point. One-way street. You could draw in another ray. You make it straight. This is the one time that it does need to be perfectly straight. And maybe this one is ray ST. So you can have lots of rays originating at point S, but they're named according to the other points that they pass through. One thing that you want to notice here is that when you have rays like this, you get angles starting to form. When you have two rays from the same end point, that forms an angle. And as soon as that angle forms, this becomes a vertex. It's that joining point for an angle. So lots of vocabulary. One is vertex. More than one, the plural, is vertices. Looks like vertices, but it's vertices. Okay, last term that we need to note on this page is a segment. And most of the time in geometry, at least if you're dealing with shapes, you're going to be dealing with segments. A segment is a straight path between 2 points. So let's use all of these terms that you've just looked at and see if we can make some sense out of this shape. Not that shape. Let me try again. I really wanted it to be... Okay, that'll work. All right, so this is a rectangle. I'm going to put some points. There's a vertex because two segments are coming together. Here's another vertex. So there's one vertex, two vertices, three vertices, four vertices. And maybe this is point A and this is point B. So there's a line segment, A to B. And then maybe this is C and this is D. So there's another line segment, segment CD. So we could say that segment AB or BA, you can go either way. These are two-way streets. The only one that is a one-way is a ray. Okay, so segment AB is what to segment CD? Well, they're an equal distance apart and they never touch, so those are parallel. So you have two segments right there that are parallel. But on this one, let me highlight a different color. Let's look at segment AC and segment BD. Those are parallel. Segment AC will never touch BD. But what would you say about this? Segment AB and segment AC. Those are intersecting right here at 90 degrees. So that is perpendicular. So once you get the vocabulary built in, You can start to use that vocabulary to describe relationships in geometry. Geometry is very, very heavy on vocabulary. And to truly understand it and to speak the geometry language, you have to know the vocabulary.